Hello everyone, and welcome to our April webinar. Today we're going to be talking about the Megapod. The Megapod is Submer's modular data center offering that integrates primarily compute, cooling, and optionally critical power modules to deliver a turnkey data center in a big box, or in a bigger box, I suppose. So let's get into it. Today, I'm going to be presenting together with Justin Cuss, who's our North America Sales Director. Hi there, Justin.
Hello, Danny.
Hello. And to start with, to warm things up, I think I'll give a bit of an insight into some of the market numbers and market trends for a modular data center. And then Justin will be digging further into the product and its capabilities and some use cases. And obviously we'll be answering any questions. So let's go for it. Regarding the growth projections of the modular data center market, it was valued at 21.6 billion in 2020, so last year, and it's expected to reach a value of 89.9 billion US dollars by 2026, which means that the market will be registering a CAGR of 27% over the period 2021 to 2026. So humongous growth is expected in the modular data center space, and we'll see the reasons and the traction where that's coming from. Obviously, some of the biggest benefits for going modular are speed and scalability. So here, for example, where the medium delivery time for a traditional data center tends to be around a year, and obviously if you run into difficulties that can extend substantially. The modular data center, the Megapod design that we have today, we are able to deliver it in 16 weeks. And that's already accounting for certain customization of the modules. So with the predefined configurations, those can actually be delivered in less. So it's a substantial reduction of the time required to deliver a data center facility, and obviously that decreases the risk and exposure during the data center build. And it's important to mention that a modular data center offers unparalleled flexibility. You can ship your data center anywhere in the world for addition, integration, or retrofitting into your existing data center footprint, and we'll see a little bit more about that in another slide. You can also combine multiple modular data centers into a single system. So although the building block, the prefabricated building block is predefined, those can be combined to build a larger facility. And we'll be showing some of the Submer building blocks for the modular data center, the Megapod modular data center. And obviously rapid deployment, as we've just mentioned, less time for assembly and commissioning, and obviously standardizing stable and reliable modules. So these are modules that have been tested. They have been tested prior to shipment, and by the time you receive them, they're ready to just hook up and switch on. And we'll talk a little bit about the standardization when it comes to also tier, Uptime Institute tier capabilities for these modules. Also, a couple of the market drivers and the improvements that Immersion brings into space The numbers are in the range of what we typically see with immersion technology, which is really tenfold when it comes to your typical modular data center densities. Typical modules tend to be in or around 100 kilowatts, some of them in lower densities than that, some of them in slightly higher densities. The Megapod has multiple configurations, the smallest starting at 100 kilowatts and the largest today at 800 kilowatts. We'll be seeing the details of in what space and in what configuration. But obviously that's the building block. That's the prefab building block that can be put together like a Lego. And then from a cost perspective, you can expect the Megapod to be in the range of 1/10 of what you would typically build for. So it's very competitive from a time to market, and also obviously from an overall TCO perspective. And that goes obviously with the small footprint, the not requiring a building around it, and everything that represents, and obviously the benefit of immersion as well. Some of the markets that are very active in the space and that we're very engaged with regarding the modular data center implementation, the mining industry, so deploying compute in awkward, harsh environments where a lot of geoscience is performed. That's one of the key areas where we see use. Obviously, fintech and high frequency trading, where we're shipping some of the first units since we launched too. So implementing high performance computing close to the exchanges, allowing for smarter decisions to be made from a fintech perspective. Energy systems and utility grids, deploying every time also more compute. So you can think of it also as compute to control and manage sensors, to gather and collect data from sensors, etc. We've seen examples in solar deployments and wind farm deployments where more and more compute is being deployed. Obviously industrial, very easy to ship and deploy a data center into a warehouse or next to a warehouse, and support large amounts of compute required to manage robots, for example. Military, no discussion about that. The benefits of lift and shift and quick deployment, of course, of large amounts of infrastructure that can be moved around in a standardized form factor that the military is already very capable of manipulating and moving around. And obviously banking, connected to fintech, I guess, same space. And the main reasons why these markets are very eager to adopt, these verticals are very eager to adopt the technology, are the same reasons that the modular data centers enable. What I'd also like to point out is when you say modular or containerized, you shouldn't think of it only as something that gets deployed outdoors on its own. There's also benefits to creating a hybrid environment where, yes, you have a shell, you have a very cheap shell, but in that shell, you can build in a very modular and cost-effective way with the scalability that modular data center enables by deploying these prefabricated modules one next to another. So I wanted to show an example of the two types of deployments that we're seeing with containerized. So yes, standalone in a car park, or in the middle of nowhere as well, but also inside of cheap shells where large amounts of compute can be deployed, and where expanding that compute is done in a very modular and fast way. So not just thinking about this is something that I'm going to put outdoors. And with that, I'm going to hand it over to Justin to show us and talk to us a little bit about the product itself.
All right, thank you, Danny. I get the fun part here. I get the show and tell of the Megapod. If you wouldn't mind going to the next slide. I think that slide does just that, the grand unveiling here of what's inside the Megapod. Our marketing team always makes me and Danny and the rest of the team look very good. So I'll, of course, it's going to close on me now too. So I'll explain on the next slide so I don't have to deal with the animation, if you don't mind. So you can see a little bit better here the what goes into a Megapod. But first, to back up a little bit to explain what is an immersion infrastructure and what does it look like. So a lot of times conversations, we start describing what immersion looks like in a data center type of setting, and people go, well, what are we missing here? It seems too easy. But to be honest, it is really that easy. So when we start talking about immersion environments, really we have three questions. How many rack units do you need? How many kilowatts is that going to push? And do you have chilled water? So that covers these three colored circles here on the left in your more typical data center environment. The pods in the blue are Submer's core business, but similar to the Megapod, we provide complete turnkey solutions with partners such as Synex, value-added partners, resellers, etc., to help us go to market. So these are complete solutions. What we do is we take all of the traditional data center components, and as we've been talking about, put them into our Megapod configuration. With the Megapod being the big brother, if you will, to our Micropod. So a couple of different outdoor or indoor ready options where we're combining the three elements, as you see, into a very modular, easy to deploy type of application. So you can see, again, what's relevant in immersion is you have our tanks, which of course have our fluid and is going to house your compute, your storage, your networking. You've got a pumping system in the orange, and you have, in this case, what would be a dry chiller, which is in the kind of pink magenta. So that's really where a lot of the efficiencies come into play. Water usage is a big thing that we come across when we're talking to customers. Immersion enables us to get rid of evaporative cooling. It's just a far more effective way to cool IT gear. So I'll talk about that in the next couple of slides. But as we mentioned, this is very modular, a lot of different options that you could put into place. Security and monitoring, obviously a very popular one that people would be interested in. We mentioned air quality. With immersion, we don't really care about air quality as far as the IT equipment goes. If you're going to be nice to your administrators and your hands-on people, you might want to cool down the inside of the container for the employee survey results to make it a little more creature friendly. But as far as IT equipment is concerned, it really takes care of any of the concerns with hot or cold when you immerse things. So fire suppression is an option. Again, to be honest, when you immerse things, it's really not needed for the fact that our liquid is a natural fire suppressant. So it's a little bit small, but you can see obviously our 8 pods in the container. We've got fire suppression built in, power, obviously the chiller. In this case, this little thing sticking down there is actually an IT crane. It kind of gets mistaken for fire suppression sometimes, but essentially on a rail system, so you can very easily move hardware in and out of the individual pods. So all this is customizable and more. Really, sky's the limit. And we love imagination. We're an engineering, innovative company, and build the suit as we go about talking to people. Next slide, please. Cool. So other than the Megapod being cool in of itself, why else are people looking at it? So when you're looking at OpEx, a potentially huge savings, right? So Danny covered the CapEx of building a data center. Your OpEx is also going to drop considerably. So the nature of immersion cooling is you're really only changing the temperature within a tank and within that cooling the water loop by about 5 degrees, 5 to 10 degrees tops. And it's just a very efficient way to cool your hardware. When you're talking about air cooling, especially in a containerized modular system, you have to deal with ambient temperatures and temperatures that are inside your container or modular data center. So if it's really hot outside, it's going to be really hot inside. And all of a sudden, you're changing the air from 100 degrees perhaps all the way down to 60 degrees to blow across your IT equipment. It takes a tremendous amount of energy to drop that temperature to where your IT equipment is going to like it. So a lot of the cooling OpEx comes in, and the fact that we just don't have to change the state of the temperature very much at all because of those ambient reasons and because of just the nature of immersion cooling. So compute density, we scale very, very linearly. In an air-cooled environment, your air conditioning it's a set limit. Your container more or less is a certain size. A lot of them, the air-cooled, you're going to have perhaps air conditioning across a sidewall of a module or a container, and it's a finite amount of cooling that can provide. So if you keep adding racks and adding on containers, you're still going to have that wall space of cooling. Whereas with immersion, every single tank we add, it's pretty easy math, right? For a 50 kilowatt tank, every smart pod is going to be adding 50 kilowatts. If you go higher density in the 100 kilowatt plus range, here we start getting up to 800 kilowatts very, very easily within a single modular deployment. So very, very fast, and you covered that a little bit too. We can hit these things, the ground running, hardware deployed in our smart pods. What we do is we essentially have the fluid meet the infrastructure wherever it's being shipped, fill up the smart pods, and we're off and running. So all that hardware can be shipped ready to go. I did touch on the zero water consumption a little bit. Again, that it goes back to the efficiency of not changing the temperature a whole lot. So we don't need water in order to cool things from 100 down to 60. So we can do this entire infrastructure in most climates with very, very little water, and in most cases, zero water consumption. So it's a big topic. As we were talking to someone in the Texas region, and I forget if it was Google or Facebook, but they wanted to build a big data center in the Dallas area and required Dallas, Fort Worth area to give them in perpetuity 1 billion gallons of water per year. And they simply said, we can't do it. So they had to go find a different home. When people start to adopt immersion cooling, we don't need any of that water. So it opens up all kinds of possibilities for these modular applications and for bigger data center applications. Obviously, carbon footprint, water, all those things go into effect across our complete portfolio. So this is a turnkey solution. We've got everything in place to deliver these and drop them in a desert over in Dubai with our friend Clinton to the United States, Europe, Asia, etc. So yeah, next slide, please.
Yeah, really to add to that, on the turnkey side, all that we're really expecting is the availability of power. There may or may not be transformers present. That's something that we can also deploy in a modular fashion through our partners, and that's it. Network and power, essentially. That's all you're going to need, and a pad probably prepared to deploy the units. But other than that, unless if you're going to deploy them directly outdoors, not much more.
Perfect, thanks, Danny. So a little snapshot here of the options we have currently. So you can see they do scale very, very linearly. So 100 to 200 in the Megapod 100, all the way up through the 400, which is the drawings, renderings, examples we've been showing with 8 of our XL Plus pods inside of it.
Yeah, and there I would only add the possibility of stacking the cooling or laying it side by side which is totally possible. The cooling module has been designed to stack perfectly on top of the Megapod.
Excellent. So while the Megapod is a very kind of slick, easy turnkey way to deploy, the core of the Submer business is the SmartPod itself. So to give a high level of what is the SmartPod, what are these neat looking black things in there with the blue lights? Most common than not, it's going to be our SmartPod XL or XL Plus. We really encourage people to think of these as either a 19 or 21-inch OCP rack, and whatever can go into what people are a little more used to thinking of, your stand-up data center rack, can honestly go into a submerged tank. So if that is storage, perfect. Compute is the most popular. Networking, PDUs, batteries, all of it can be immersed. There's really not a whole lot of tricks to it. There's certain vendors that we'd be happy to discuss, one-on-one, where we have relationships for certain reasons that we tend to prefer. But at a high level principle, there's very few steps that have to be taken for anything to be immersed in our dielectric fluid. It's 8 times less conductive than air. It's just a very, very safe, friendly environment for things to sit in. So if you open the door to go into this modular data center, all of a sudden, dust, wind, sand blows in, you're very safe when you're in our fluid. So it's about the safest you can make an IT environment, especially when you're talking about at the edge or outdoor applications. A couple other things about the pod here. Oops. Back quick. I was just going to cover the CDU, if you can hit back quick. Perfect. So yeah, just one last thing here on the SmartPod. So what a SmartPod consists of, you have water coming in from the dry chiller. It's going to interface in what we call a cooling distribution unit, which are the silver items here on either side. And those are really kind of like a 2U rackable form factor. It really sets us apart compared to anyone else trying to do this, in that they're hot swappable, completely integrated. That's where the brains and the guts of the tank are. So we measure all the things that you would expect, from temperature to flow rate, the complete health of the entire system. That's where the brain is there. It's got redundant pumping in each of those CDUs. So in this case, the XL, we're going to have 2 CDUs, with each of those having 2 pumps that trade off on a regular basis. So a level of security there as well. You can lose components if this is in a remote area where your mean time between repair is long. We can also withstand some failure within our systems as well for those type of applications. So very resilient, very well thought out, and self-contained, easy to maintain SmartPods that Submer has come up with. Excellent. So a little bit on the pumping system. Speaking of resiliency, we do have redundant pumping. Again, the Immersion is a very simple ecosystem. So pumping water from the dry chiller to the SmartPod, and then those pumps that I covered in the CDU in the SmartPod itself, they're going to be the only moving things in this entire modular data center. So fans are removed from whatever is going in the fluid, and you eliminate just so many moving parts and so many areas for failure from a mechanical perspective. Again, not to mention on top of the environmental aspects of being in immersion, and you get a very, very high level of resiliency from all the mechanical components to the fans to the hardware itself that's going into each of the SmartPods. So a lot of people ask about, you're sticking this thing in the desert or all kinds of creative different places to put a modular data center. So I want to point out that we are tier ready, as we are very adaptable to different people's needs. We can scale up and down the tier level depending on people's needs for certification for the reliability and resiliency that they have for their data center build out. So to kind of summarize the tier ready, so these are pre-validated designs. These are reference architectures that we've built out and designed. It really, being its turnkey, it reduces your time as an end user or partner to get that certification, right? We can provide the pre-validated designs to really help through that process. And of course, when you're not putting engineering time, effort, et cetera, into it, the cost is lower from the actual building to the components to OpEx, but then of course in the design of the tiering and in the scope and certification for that as well. Okay. A couple examples I wanted to share, and then after these, I believe we've got some Q&A. So one end user case that we recently solved was a case for really needing an instant data center. So this is going to be more of an augmentation of a current data center. So they had a scenario where their primary data center was full. There was not a lot of things they could decommission to make extra space. And so there was not a lot of area to do a remodel either, right? They were just kind of stuck and full, and what was there was there. There wasn't a lot of hardware that was up for decommissioning. This was a pure kind of add type of scenario. So the cost to remodel was high, and it really wasn't a great option, again, because the floor space was already spoken for. They looked at other offices, and those really weren't data center ready. With Submer and Immersion, right, with how simple it is, it was more of a possibility, but what they really wanted to have was a dedicated immersion, dedicated area to build out in a modular data center was just the ticket for them. So we provided a turnkey data center in a Megapod. We didn't really have to deal as much with the harsh environment type of problems, but definitely needed a high tier, reliable, redundant data center that we were able to provide very high GPU based hardware, which lends itself very good to immersion, period. And then add in the fact that we could deploy that just so much more quickly to meet their business timelines and business needs was another huge plus for them. They did want to relocate to an area closer to some fiber hubs for latency reasons. So being that these can sit anywhere and they're very secure, that was another plus in this case. And then the ability to expand easily as their business grows. They no longer have to deal with huge CapEx remodels, architects. We simply bring in the old 18-wheeler, slide it off, and more or less plug and play data centers was very appealing in this case. And then the next one, we've talked quite a lot about the remote, harsh type of locations. So again, air conditioning, just really not very scalable. The competitors that we've seen, again, may take up a whole side, so 40 feet of air conditioning, but a lot of the scalability comes in adding containers behind it that don't have air conditioning. And even if they could, there's only so much air you can force through an area, combined with the fact that the new AMD and Intel processors that are coming out, if you get the platinum highest end processors, you really can't air cool them even in a pristine data center type of environment anymore either. So you really kind of have a double hit of air not being able to do enough anymore. It's in a harsh environment where just your physical area of air conditioning is limited, and you have the actual hardware limiting you with the demands it needs for the cooling capacities. Combined with ambient air temperature, which I covered, if it's 100 degrees outside, you have to deal with that in an air-cooled environment to drop that down to a good degree. So Immersion was just a great fit for this opportunity. Air filtering, of course, when you're pulling a ton of air through the side of a modular data center. So think about OpEx again, less power generation needed because we just don't need the power of condensers, fans, all those different things. So you can save on diesel, gas, the actual physical generator for the power need. We scale very, very linearly for easy add-ons. Of course, we have a safe, fluid environment for all that gear to sit in. There's just the ambient heat. I think we've covered that. And again, when you're shipping fully integrated with server, storage, networking already configured, ready to go and plug and play, you don't have to send nearly as many people to the remote harsh environments to get your full data center deployment up and going. So I think with that, we're on to Q&A.
Thanks, Justin. Yep, we'll jump into the Q&A, and what I'll do is I'll stop presenting so I can see some of the questions, because we have a few. So great. This is a question from Brian. What is the flexibility for power distribution within the Submer pods? Is it strictly the most common AC distribution, or is it also possible to handle DC distribution, which seems to be picking up more traction in data centers? So that's a great question. And we actually enable both. So AC, let's say typical AC power distribution through PDUs, your typical back of the rack PDUs, 0U PDUs, those are integrated into our SmartPod in the dry zone, so they're not submerged. And that's the typical way that we'll distribute AC power to the nodes. And DC power, it is the trend, of course, and also in OCP, it is the standard in Open Compute, where bus bars, 12 and 48 volt bus bars are leveraged at the bottom of the tank to supply DC power. All those systems, meaning the power shelves that transform AC to DC, are submerged in the tank, but there's nothing limiting us from also leveraging direct DC to a bus bar without that conversion. So totally possible to run telco grade DC in the Megapod platform, and in general in the SmartPod. So yes. Another question from Brian as well, is the heat exchanger always within the pod, keeping the dielectric strictly within the pod and water, or other external via the heat exchanger? So the heat exchange occurs in the pod. The CDUs that Justin was describing are submerged in the pod. And not only do they include redundant pumping, they also include a heat exchanger. So the heat exchange occurs in our tanks, in our fluid, and the heat of the immersion fluid is transferred to the water loop in that CDU, which means that that's where it happens. It happens in the tank. The fluid never leaves the tank, the immersion fluid. Although we are looking at configurations where we take the fluid all the way to the dry cooler. That is something that we're testing as we speak, because there's some levels of efficiency. There's essentially one fluid loop less, there's no water loop. And the efficiency of the system and the reliability of the system would be even better than an environment where there's more than one loop. Another question, great. So Irfan is asking us, can a cooler be shared across multiple pods? What was the limiting factor for 800 kilowatts? What is the size of the container? Good question. Okay, so we can build, if we're deploying multiple megapods, so compute pods, it will probably make sense to deploy less dry coolers. So instead of matching one megapod with one dry cooler, we'll essentially deploy a bigger dry cooler, or we'll size the dry cooling infrastructure depending on the tier requirements. But you can imagine, for example, a deployment where you have, let's say, 10 megapods, and you're connecting 10 megapods to 5 dry coolers, for example, 5 1.5 megawatt dry coolers, which exist today, or 2 megawatt dry coolers, which are also available. So that's completely possible. What am I missing? What is the limiting factor for 800 kilowatts? The limiting factor is that today without doing anything special, the SmartPod XL platform supports 100 kilowatts per immersion tank with very warm water temperatures. So if the water temperature is colder, those 100 kilowatts can go higher. It's how we've sized the system today, to say the truth, because although single-phase immersion cooling allows us to achieve much more, until the IT equipment doesn't catch up, and no one's seen a 100 kilowatt rack yet. I'm hoping we see one soon. But obviously we have the capability of designing CDUs that will enable more than that, which is part of our roadmap, of course. So it would be as simple as replacing the CDUs that are in that tank for a new generation that will enable more dissipation, more heat dissipation. But the limiting factor is that essentially in a 40-foot container, which is the size of the Megapod 400 and Megapod 800, we have 8 immersion tanks. And if we leverage the SmartPod XL at 100 kilowatts per immersion tank, that gives us the 800 kilowatts that we're capable of delivering today. The containerized option ranges in different configurations, as we were showing before, from the 10-foot container configuration with just 2 SmartPods in there, all the way up to the 40-foot container configuration, which can host 400 kilowatts of tier 3 fully redundant compute, or 800 kilowatts of tier 2 in a tier 2 configuration, let's say. Can you provide a breakdown of the costs of the various components, pods, container, cooler, etc.? What I can say is that the solution works typically, so it's always less. Whatever we do, we are below the range of 1 million per megawatt, $1 million US per megawatt for sure. Even in a fully populated, obviously not with servers, but that's the SmartPods for an 800 kilowatt system, let's say. The SmartPods, sorry, for a megawatt, let's calculate it in megawatts. The threshold is below 1 million per megawatt, let's say, and that includes the primary cooling, so the immersion systems and the fluid, the secondary cooling, so the water loop and the dry coolers, the electrical, fire suppression, monitoring, security and access control, and a few more things in there. I have one more question. What is the difference between your Micropod and the Megapod? I'll leave that one to you, Justin.
The baby brother to the Megapod is the Micropod. So another great edge deployment option. So the Micropod is going to be in a 6U form factor. It is also very, very turnkey. So put 6U worth of hardware in there. It's going to range a little bit on the density, whether it's in direct sunlight, shade, indoors, etc. But think anywhere from 5 to 9 kilowatts in 6U. So for an edge deployment, very, very dense for what people are doing at the edge. It's going to have the dry cooler or the secondary cooling attached to the immersion bath itself. It's on casters. You can think the bottom of cell phone towers. You can think office in a box. You can think actually one of the POCs we have going on is on overhead signs, basically over highways to do toll tag recognition, facial recognition, license plate recognition. So I think that's just a great example of where someone needs some compute at the edge, certainly in a protected environment. We've talked to people around smart signage, putting things on a Micropod kind of in between billboards for having smart signage, electronic signage. So just think density at the edge. Little density, portable density, Micropod's your guy. And if you want to roll in a megawatt of compute anywhere in the world, the Megapod's the one for you.
Thanks, Justin. And with that, I don't see any more questions, so I think we can close it here. Oh, look, here's one. What is the noise level of a Megapod? Let's take this one before before we close it. So the noise level of the dry cooling infrastructure that we're leveraging. Actually, let's start with the inside of the compute space, because that's a big difference with traditional. So inside the compute space, the noise level is 37 decibels, which is the equivalent to the noise in a library. That gives you an idea of how silent the Immersion technology is. It's just a very light humming sound. Obviously, if you refer to the outside infrastructure, the dry cooling infrastructure, the dry coolers that we're leveraging are in the range of 55 decibels at 30 feet. That's how they're measured. So they're quite optimal for deployment in populated areas where there's people close to them. Those values can be brought down even further by integrating air tops, as they're called, into the dry cooler fans, which is essentially a module that attaches onto the fan. And not only does it improve its efficiency, it also brings down the noise by 5 dBs. So that's a very cheap way of silencing even a little more the dry coolers, but they're not very noisy. 55 dBs from a 30-foot distance, which in a city it would be really hard to hear them for sure. Okay, and I think that was the last question. So with that, we'll leave it here. Lastly, I'd like to invite everyone to visit our, obviously stay tuned on our socials. We're very active, as you've probably seen, and feel free to reach out to Justin or myself if you have any further questions. We hope to have clarified a little bit what the Megapod is and the advantages that it brings, and really appreciate everyone's time. Thank you very much, and see you in our next webinar.
Submer, data centers that make sense.